Welcome to NeuroDriveAiReels. Have you ever wondered what it would be like to ride in a car that thinks, heals itself, and truly understands you as its owner? Imagine stepping into a vehicle that adapts instantly to your mood, anticipates dangers before they happen, and even repairs itself after a minor collision. This isn't science fiction. It's the dawn of a new era in mobility. Today, we explore the technologies shaping that future and the ethical questions they raise. First, consider self-healing AI car materials. Picture a small dent or scratch appearing on your car's surface, and within seconds, the damage vanishes. Nanobots and responsive polymers work together to detect and repair imperfections instantly, keeping your car pristine and, more importantly, safer. But this isn't just about aesthetics. Imagine an accident scenario where the car's frame can adapt its shape in milliseconds to absorb impact and protect passengers, pedestrians, and other vehicles. These materials don't just heal, they respond. And that leads to a question. If a car can change its physical structure to optimize safety, who decides how it should respond? The engineers, the algorithms, or the law? Now picture your hands on a haptic feedback steering wheel. Have you ever felt a car communicate with you through touch? Slight vibrations, gentle resistance, or subtle nudges guide your hands, warning of lane departures, hidden obstacles, or pedestrian crossings. In a split-second scenario, the AI might nudge the wheel to prevent a collision or resist steering to stop an unsafe maneuver. This intimate form of guidance raises fascinating ethical questions. If the car acts in a way that overrides your decision, are you still in control? And if the car misjudges a scenario, who is accountable? The driver or the AI? The stakes are high because haptic feedback is not just technology, it's the language between human instinct and machine intelligence. Step inside the cabin and witness AI-powered personalization in action. The seats adjust automatically to your posture, temperature controls shift to your comfort, and ambient lighting changes to influence focus or relaxation. The infotainment system anticipates your music preferences, navigation routes, and even suggests breaks when you're fatigued. Biometrics play a key role here, measuring subtle cues such as heart rate, eye movement, or micro-expressions to adapt the environment. But personalization goes beyond comfort. It influences behavior. An AI interior that understands your state can subtly nudge you towards safer driving habits, slowing down when you're tired, or alerting you to hazards before you notice them. Yet this raises profound questions about autonomy and consent. How much should your car intervene in your choices, even for your own safety? How do we balance human freedom with machine-guided protection? Biometric security is another frontier redefining ownership and trust. Imagine a car that recognizes you through iris scans, fingerprints, or even unique driving behaviors. No keys, no codes, just you. This system prevents unauthorized use, improves safety, and enables the AI to adapt ethical decision-making based on who is behind the wheel. For instance, the car might drive more cautiously if it senses inexperience, or alert authorities if it detects erratic behavior. But with this power comes responsibility. Biometric systems gather vast amounts of personal data, raising concerns about privacy, hacking, and misuse. In a world where cars can make autonomous decisions, how much data is too much? How will we regulate the line between safety and surveillance? Now imagine a real-world ethical scenario. Your car is driving autonomously when a sudden hazard appears. A child steps onto the road, and there's no time to stop. The AI must decide, swerve and risk hitting another vehicle, or brake and risk passenger injury. These split-second decisions are where technology meets philosophy. Engineers and ethicists are debating the moral frameworks guiding AI cars. Should the algorithm prioritize the lives of passengers, pedestrians, or the greatest number of lives? And as these vehicles communicate with each other and with smart infrastructure, the stakes become societal. Autonomous fleets could optimize traffic, avoid collisions, and even coordinate emergency responses, but they also inherit the ethical biases of their creators. How do we ensure fairness, accountability, and transparency? Beyond individual cars, imagine a city of AI-driven vehicles working in perfect synchrony. Traffic flows smoothly, accidents become rare, and energy efficiency is maximized. Drones, smart traffic lights, and pedestrian AR displays all communicate with cars, creating a network where every decision is shared and optimized. This future promises incredible benefits: reduced congestion, safer streets, and efficient logistics, but it also relies on trust. Humans will need to relinquish control in critical moments, trusting algorithms to act in life-and-death situations. How society navigates this transition will define the safety and ethics of tomorrow's roads. Let's return to the personal experience. You're behind the wheel, or rather in the driver's seat as a passenger in your autonomous companion. The dashboard glows softly, projecting critical data, while haptic feedback guides your hands gently. The AI interior adjusts lighting to ease your stress, music shifts to focus your mind, and biometric sensors monitor your attention. You realize that every feature, every nudge, every adaptation is part of a larger system designed not just to drive, but to think, anticipate, and protect. Self-healing materials respond to impacts, haptic systems prevent errors, AI personalization supports your behavior, and biometric security ensures trust. It's a symphony of technologies converging to redefine mobility. But here's the ultimate reflection. As AI cars become more intelligent, ethical decisions cannot be an afterthought. The algorithms must balance lives, anticipate human error, respect privacy, and build trust. Urban planners, lawmakers, and technologists will face unprecedented challenges. Should cars intervene aggressively to prevent accidents? Should they account for driver personality, age, or risk tolerance? How will liability and accountability evolve when machines make choices faster than human comprehension? These questions are not hypothetical. They are pressing dilemmas, shaping the very streets we drive on. Imagine a future scenario. A car senses an emergency vehicle approaching, a pedestrian crossing unexpectedly, and a construction zone ahead. In a fraction of a second, it calculates multiple outcomes, weighing every life, every possibility. It chooses the optimal path, not just for you, but for everyone around. This is the ethical complexity of autonomous driving, a combination of advanced sensors, predictive algorithms, and moral reasoning. The AI's empathy is coded, its decisions precise, but still grounded in human values. How do we trust a machine to weigh moral choices? And how do we ensure that these values align with society's expectations? Now zoom out. Picture the city at night, neon reflections on rain-soaked streets, drones hovering, and AI vehicles communicating seamlessly. Each car adapts its behavior, preventing collisions, optimizing speed, and prioritizing emergency responses. Self-healing materials glint as minor scratches vanish instantly. Haptic feedback subtly guides those still manually controlling their cars, and interiors adjust dynamically to driver state. Biometric security ensures only authorized users can access vehicles, and AI personalization predicts needs before they are consciously felt. It's a vision of mobility where technology and ethics converge, a future where roads are alive with intelligent, conscientious companions. Finally, let's reflect. The promise of self-healing AI materials, haptic steering, personalized interiors, and biometric security is extraordinary. These innovations can save lives, enhance comfort, and reshape urban mobility. Yet they also challenge our understanding of responsibility, trust, and autonomy. As AI assumes more decision-making power, society must decide how much control we're willing to delegate, how privacy is protected, and how ethical principles are encoded into machines. So here's the question for you. If you had to ride in a car that made life and death decisions, how much would you trust it? And why? Would you embrace this futuristic companion, confident in its intelligence, or hesitate, questioning whether it truly understands what it means to protect life? The future of mobility is not just about technology. It's about the choices we make today and the trust we place in the machines of tomorrow. Guess what? The future of driving might not even involve us touching the wheel. And it's not just about self-driving cars. It's about entire cities, powered by artificial intelligence, moving like one living organism. This AI feature could change driving forever, and maybe even the way we live in our cities. Imagine this. You're in a car, and it feels like traffic has disappeared. No honking, no jams, no endless waiting at red lights. Why? Because AI isn't just driving your car. It's managing the entire city's traffic flow. Like a digital conductor leading a glowing symphony of roads, every movement is orchestrated. Early versions of this already exist. But in the future, intersections may not need lights, highways may breathe with adaptive surfaces, and the entire grid might think like a living brain. Instead of cars competing for space, they'll be collaborating in real time. But here's the twist. Mobility isn't only about movement. It's about decision-making. Picture this. An AI car is traveling with you inside. Suddenly, a child runs across the road. The car has milliseconds to decide, swerve left and risk colliding with another vehicle, or slam the brakes too late. What should it do? This is where ethical algorithms come into play. These aren't just lines of code. They're life and death formulas. And the hard question is, who writes those formulas? Engineers, governments, or maybe one day, the passengers themselves? Now imagine future cities as living, breathing systems of mobility. Streets won't just be concrete, they'll be adaptive. Buildings might shift their lighting in response to traffic flows. Roads could flex or expand digitally to absorb sudden surges in movement. There may even be entire districts where human driving is forbidden. Only AI mobility is allowed. It sounds futuristic, but versions of this are already being tested. Smart roads with embedded sensors, overhead drones acting as traffic controllers, and AI centers monitoring congestion in real time. Today, it's small-scale. Tomorrow, it's entire megacities humming in perfect coordination. Guess what? For millions of people living with disabilities, AI cars could be more than futuristic gadgets. They could be freedom itself. A blind individual guided to a vehicle by an AI voice. A wheelchair user rolling into a car that adapts its seating automatically. A stroke survivor regaining independence, not from medicine, but from mobility. Tomorrow's cars won't just be faster or smarter. They'll be more human in design, anticipating needs before they're spoken. But let's not sugarcoat it. The more power we give AI, the more trust we must surrender. What if your car must choose between protecting you and protecting pedestrians? What if different cultures disagree about whose life matters more? Do we standardize ethics, or let every country, every company decide differently? The nightmare isn't just crashes, it's mistrust. A single bad decision could shake global confidence overnight. Think about it. Would you ride in a car that millions of people no longer trust? To solve this, future mobility won't just need engineers. It will need philosophers, regulators, and yes, everyday riders like you. Laws may soon dictate how AI cars are allowed to value human life in impossible scenarios. Insurance contracts might be rewritten to handle AI mistakes. Governments could demand black boxes in cars that record every AI decision, like flight recorders in planes. And at the center of it all lies one fragile idea: trust. Without trust, the system fails. Without trust, the future doesn't move. Fast forward to 2050. Cities have changed. Roads aren't just roads. They're adaptive surfaces glowing softly with responsive lighting. Parking lots? Gone. Cars no longer park, they circulate like blood cells in a living organism. Highways? No longer static scars of concrete, but glowing rivers of coordinated movement. And the most inspiring part? The elderly, the disabled, the isolated, all moving freely with independence. What once felt like dystopia has become liberation. But here's the kicker. This isn't far away. It's starting now. Pilot AI traffic systems in Singapore, New York, and Tokyo. Early autonomous shuttles moving through quiet districts. Startups designing cars built specifically for people with disabilities. Tomorrow's breakthroughs are being tested today. And when the scale tips, when we go from thousands of AI cars to millions, it won't just change how we drive. It will change how we live, how we build, and how we think about movement itself. So here's the question I'll leave you with. If you had to ride in a car that made life and death decisions, how much would you trust it? And why? Have you ever imagined a world where your car isn't just a vehicle, but a living node in a citywide conversation? Picture a neon-soaked metropolis at dusk, glowing streets reflecting holographic signs, autonomous vehicles gliding smoothly along bioluminescent lanes, and every car communicating silently, instantaneously, with every other vehicle around it. The city doesn't just function, it hums, pulses, and flows as if alive, each car exchanging data, predicting motion, and adjusting its path in a symphony of glowing precision. Imagine stepping into your car, the dashboard bathed in soft cyan and magenta light, sensors scanning the streets, pedestrians, and even the micro-movements of nearby drones. Your car knows when the vehicle ahead is slowing, when a pedestrian will step off the bioluminescent crosswalk, and even when a distant intersection will light up with traffic congestion. It adjusts in real time, braking, accelerating, and guiding itself with a grace and fluidity that feels almost organic. Trails of luminescent light follow each car as they glide past, reflecting on wet asphalt, creating a living map of motion across the neon cityscape. Now consider the implications. Car-to-X communication, or V2X, vehicle-to-everything technology, allows vehicles to exchange data, not just with each other, but with traffic signals, road sensors, and even city infrastructure. Imagine traffic lights that glow dynamically, pulsing in sync with traffic flow, or highways that shimmer with light patterns indicating the optimal speed for every lane. The city itself becomes a living organism, responding and adapting to each car's needs, and each car contributing to the rhythm of the urban environment. Think about safety. Split-second decisions are no longer left to human reflexes alone. If a vehicle ahead detects a sudden hazard, a cyclist weaving through glowing streets or debris on a wet lane, it communicates instantly to surrounding vehicles. Cars coordinate braking and evasive maneuvers in perfect harmony, a glowing ballet of movement across neon asphalt. Every light, reflection, and trail tells a story of data, prediction, and shared decision-making. Accidents that once took seconds to occur can be prevented in milliseconds. But this technology isn't just about safety, it's about efficiency. Picture your commute, vehicles communicating in real time to eliminate stop-and-go traffic. Traffic jams become memories as cars dynamically adjust routes, speeds, and lane positions. Bioluminescent lanes shift and pulse to indicate optimal paths. Flying autonomous taxis glide above, synchronized perfectly with ground traffic. The city flows like liquid light, a cyberpunk river of motion guided by invisible intelligence. Every street, every intersection, every neon-lit corner is connected in a vast network of predictive knowledge. Car-to-X communication also opens new doors for urban planning. Imagine streets designed not for humans alone, but for networks of intelligent vehicles. Dynamic lanes glow to indicate temporary changes, sidewalks light up to guide pedestrians safely, and parking spaces communicate availability in real time. Cities could shrink or expand road capacity on demand, and streetlights pulse with bioluminescent patterns that harmonize traffic flow. Infrastructure and vehicles are no longer separate. They are components of a glowing, synchronized system, a city breathing with intelligence. Social implications are equally profound. Autonomous, communicating vehicles could democratize mobility. The elderly, disabled, or those without licenses gain freedom, moving safely through neon-lit streets guided by intelligent networks. Communities once separated by geography or traffic inefficiency could merge seamlessly. Yet, this reliance on AI and communication networks raises questions about privacy, trust, and dependency. Every car is a node in a glowing web of data, and every movement leaves a digital footprint. Who controls the network, and how is trust maintained across billions of instantaneous interactions? The technology itself is a marvel. Vehicles use sensors, LiDAR, radar, and AI to communicate with each other at lightning speeds. They predict hazards before humans can perceive them, negotiate intersections without traffic lights, and anticipate changes in city infrastructure. Imagine an intersection lit with bioluminescent signals that dynamically adjust as approaching cars talk to each other. Vehicles slow or accelerate with subtle precision, leaving luminous trails that map the choreography of motion in real time. It's safety, efficiency, and elegance wrapped in a glowing neon glow. Yet challenges remain. Communication networks must be secure, resilient, and ethical. Imagine if a malicious signal interfered with traffic coordination. How do we safeguard trust? How do we design AI systems to make fair, ethical decisions when multiple paths or lives are at stake? The neon city is beautiful, but it is also a web of responsibility. Regulatory frameworks must evolve as fast as the technology, balancing innovation with safety, efficiency with human values. Every bioluminescent reflection becomes not just an aesthetic choice, but a symbol of shared responsibility. The future could extend beyond Earth. Imagine Martian or lunar colonies where autonomous vehicles communicate across glowing engineered roads. Each rover, each transport pod, each flying drone exchanges data to optimize travel in extreme environments. Lessons learned in cyberpunk neon cities on Earth will inform AI-driven infrastructure across worlds, blending human ingenuity with predictive intelligence and luminous guidance. Consider the human experience. Commuting may no longer be stressful. Instead, travel could become seamless, immersive, and even beautiful. Augmented reality displays could overlay glowing navigation cues onto windows, guiding passengers safely and elegantly through the cyberpunk cityscape. Pods could anticipate passenger needs, adjusting lighting, temperature, and speed in harmony with external traffic and internal comfort. Every journey becomes a collaboration between human and machine, between choice and algorithm, between neon reflection and bioluminescent trail, and the cultural impact is just as profound. Cities filled with glowing vehicles communicating in real time could redefine how societies understand mobility, trust, and public space. Urban life becomes a networked dance of decision-making, every street and highway a luminous ecosystem. Humans must adapt to coexist with intelligent networks, learning to trust their vehicles while questioning, reflecting, and guiding the ethical frameworks that govern them. The city is alive, and we are both spectators and participants. Finally, reflect on the global possibilities. Autonomous communicating vehicles could reduce accidents, emissions, and congestion worldwide. Networked intelligence could allow cities to share data and optimize mobility across continents. Bioluminescent highways, neon-lit traffic hubs, and glowing urban arteries could create a new era of safety, efficiency, and aesthetic wonder. But all of this depends on choices we make today, the algorithms we trust, the infrastructure we build, and the ethics we prioritize. So I leave you with this question. If every car on your street could communicate instantaneously, anticipating hazards and traffic flow with perfect precision, how much would you trust this network? And what rules would you want it to follow?